Hello, testing, testing. Bar on OBS is going up. I think that's a good sign. Bam. Hello, I'm here. Good evening. It's nighttime in my time zone. Or good morning, afternoon, wherever you are. Let me get my Chrome window up. Where's my Chrome window? Oh. Alright. There's my Chrome window. Alright, so for context, we have been learning how to read code in Python. I've been doing the blind 75 Leetcode questions. I finished the array section, we skipped the binary section, and then we're starting the dynamic programming question. Very exciting. I can't wait to get past this. It feels like we've been stuck in these first two sections forever, partially because I switched from Java to Python halfway, so I had to cover my bases again. But hopefully we'll make it past and we'll get to the graph area soon. but for now we're here on climbing stairs. Okay, here we go. Kinoe says hi. Hello, hi Kinoe. Welcome to the stream. Do you Leetcode? Okay, climbing stairs. Allegedly an easy question. You are climbing a staircase. It takes n steps to reach the top. Make this bigger so people can see. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Okay, so I guess you're given n equals a integer which represents the number of steps in your staircase, and your goal is to return the number of ways you can climb to the top, assuming you can either take 1 step or 2 steps at a time. I kind of remember this problem. Kinoe says Python? Yes, Python. I am doing it in Python. Okay, let's say we have a stairs here, right? 1, 2, 3. We're starting at the bottom here. I swear I've drawn this picture like 3 times already. So we can either climb 1 step, or we can climb 2 steps. What if I'm already on the top over here? I guess this would be the case where maybe n equals 0. If you have no more steps to climb. Fortunate God says Mac OS on Windows. Should I try it or not? I have no clue. Why would you want Mac OS on Windows though? For ease of development? I've heard people installing Mac on Windows just because they can install development tools better. What are you... I heard you're trying VTubing recently, right? And you're trying to make games. I'm not sure. You should do some research. Maybe ask ChatGPT. If n equals 0, that's the base case, then that means return 1, right? You've gone to the top, you found one way to get to the top. Else, we should probably return a recursive function where you take 1 step, n minus 1 like that, or of n minus 2. Right? I guess we're going the recursive case here. I suck at thinking about dynamic programming from bottom-up style. I like to do the recursive approach and then memorize it. So base case is if n equals 0, that means we've already reached the top. And we can return 1, meaning one way has been found to reach the top. Looks like a factorial function. A factorial function. How is it a factorial function? Well, I'm thinking of it as recursion. So if you're not at the base case, then you try taking 1 step. How many ways are there after taking 1 step? Plus, how many ways are there after taking 2 steps? That's my plan, I guess. Is it actually a factorial thing? I think I'm going to try it with recursion first, at least for now. Okay. So climb stairs. Base case is if n is equal to 0, then return 1. Else your base case is return climb stairs n minus 1, plus climb stairs and minus 2. Wait, I just thought of another case. What if you like overstep like that? That means you probably like, what if you were like here and then you overstep like twice like that? You took 2 steps and you're out of bounds now. That's bad, right? We shouldn't count that as a valid case, I suppose. Because if you're sitting at the second to last step, you should only have one way to reach the top, not 2 ways. So if n is less than 0, return 0. Else do the recursive cases. Oh, double equals sign. Climb stairs. Do I have to pass self in? Huh. What is up with this? Self.climb stairs? Self.climb stairs? Is this the only way to pass in the self variable in? There we go. We're gonna get time limit exceeded, aren't we? And then we're gonna have to do some memoization. Yep, time limit exceeded. It's even worse in Python. Time limit exceeded. No. Okay. It's time to use a cache. For caching, we can probably just use a dictionary, right? Now it looks like a Fibonacci function. Oh, wait. Wait, is it like a Fibonacci function? Okay, wait. Let's do... What if the staircase is 1? Then you return 1 step like that, so it's 1. What happens if you have 2 steps? 1, 2, 1, 1, 2, 2, 3 steps. One, two, three. Oh, this is the example I have. So 1 plus the number of steps for 2 steps, which is 2, which is 3, plus 1, 2. Wait. 1. Is it? Wait, I'm getting confused. So 1, 2, 3. You can do 1, 2, 3 like that. You can do like this. That's another one. Or we can do like 2 steps and then here, right? So that's 3. What about 4? So starting from here, you can take 1 step. 1 step plus the number of takes to 1, 2, 3 to take 3. So 3 plus... Ah, I see. Krishna says, hello, hello. 1, 2. You take 2 steps, and then it's the solution it takes to take 2, starting from 2. Plus 2 equals 5. So it is kind of like Fibonacci. It's always a good idea to read the question again. I do it all the time. I see. Actually, I don't think I would have saw this pattern if I just read the question again and again. It's only if I... yeah, it's only if I like look at the first few values, I'm like, oh yeah, it is kind of Fibonacci-ish. Okay. So what do we do here? We can do, what are our base cases? So if n is equal to 0, or n, oh, I don't need these parentheses. If n is equal to 0, is there a case where n is equal to 0? Or n is equal to 1, then return 1. Else you return wait, I'm still doing top-down recursion. That's the base case. How do I do this Fibonacci style without recursion? Previous is equal to... wait, actually that's an okay base case, right? So if n is equal to 0 or n is equal to 1, then return 1. That's a fine base case, right? Else you actually do the adding and subtracting. So previous is equal to 1, current is equal to 1, and while I guess current level, the question says you can climb 1 or 2 steps at a time. Yeah, it does. Wait, how do you do, what's the best way to do Fibonacci? Do I have to store like a current level is equal to 2? 1? While the current level is less than n, then current is equal to previous plus current, and then the previous is equal to current. Does that work? Oh wait, this doesn't work. Because current is overridden. Temp is equal to the current, does that work? So then you can update the current here. Current is equal to previous plus the current. Okay. And then previous is equal to temp. And then current level plus plus. Plus equals 1. And then you would return current. Okay, let's do a sanity check. Let's walk through this code. If n is equal to 2, what will we do here? N is equal to 1 or n is equal to 1. N is equal to 0 or n is equal to 1, return 1, that's fine. Current level is equal to 1. Well, current level is less than n. Well, 1 is less than 2, yeah. Temp is equal to current. Current is equal to previous plus current is 2. Previous is equal to temp 1. Current level plus equals 1, so current level is now equal to 2. This solution is no longer correct, so we return current. I think that's correct. Nice. Hey, let's go! Thanks, Kinoe, for the hint. How do I pronounce your name, by the way? Is it Kino or Kinoe? Kinoe? Look at that. We beat it 100%. Nice. Yeah, I still don't think I would have spotted the pattern just by reading the question. It's only if I see like the pattern of the results, I'm like, oh, this is Fibonacci. Anything is okay. Okay. Next up is coin change. You are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins you need to make up that amount. If the amount of money cannot be made up by any combination of the coins, return -1. You may assume that you have an infinite number of each kind of coin. Ooh. Okay. I'm sure Kino is going to tell me to do some bottom-up dynamic programming thing again. I'm going to try recursion again because my tiny brain can't possibly process how bottom-up works in this case. One, two, five. Fewest number of coins you need to make up to that amount. Actually, realistically, can't you just keep taking the biggest coin that doesn't exceed your current, value that's left? Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. I mean, even without recursion, let's say the output is 3, you would try like 5 first, right? And then you're like, okay, 5 exceeds the value. What if we try 2? What if we try 1? Oh, actually the amount is 11. So we would try 5, and then 2, and then 1, I don't think recursion would work properly. It's possible though. I want to try the strat that I just described. What if we keep trying? What if we take... I don't know, what if we keep trying? Like, how many times does the biggest coin divide into the amount? How many times does the next biggest coin divide into the remaining amount? That kind of deal. So in this case, like, the amount will be like 11, right? 11 divided by 5 equals 2. So you'd be like, okay, 11 minus 10 equals 1. And then we'll check the next coin, right? 1 divided by 2 is equal to 0, so nothing we can do there. 1 divided by 1 is equal to 1. So you add these together, to 3. What about this one? Amount is 3. 3 divided by 2 is equal to 1. Divide, that would be a problem if the number is prime, no? Oh, I meant floor division? Or division? Like that? Does that work? 3 minus 2 is equal to 1. Yeah, and then your remaining value over here is not equal to 0, so you're like, oh, we're screwed. right? I feel like that works if we're trying to not use just blind recursion. Coins.length is, oh, our coins array length is limited too, so it feels like we can totally do something like this. I feel like that'll work, yeah? So I feel like first we need to sort our coins. Leetcode is the best. Pseudo bliss. Is Leetcode actually the best? I guess it's the only site to practice coding questions like this. Wait, what other sites are there? I don't even know. Okay, my plan. HackerRank? Oh, right, there's HackerRank. I've never heard anyone say anything good about HackerRank. Okay, let's try something. Let's first sort our coins. Coins.sort. Code forces. Oh, I've heard of that. I never tried it though. Let's find out what our coins is currently. Let's return -1 as bogus value. I'm just trying to make sure I sorted the coins correctly. 125, okay, nice. We should track our remaining amount equal to the amount. And then for every single coin in coins.reversed, I don't even know if this is a thing confidently in Python. Print coin has no object reversed. Is it reverse? Python, how to reverse list. Reverse method, dot reverse, mylist dot reverse. Coins dot reverse. Is this not what I'm doing? Or to iterate through list backwards. Reversed? Oh, it's a function that operates on the list. Reversed coins. Five, two, one. Okay, nice. The function reverses the list. I see. Okay, this is my coin count is equal to 0 so far. So we would do remaining amount coins needed is equal to remaining amount floor division by the current coin. Remaining amount minus equals the coin value times the coins needed. And then coin count plus equals coins needed. And then you would return coin count, but only if the remaining amount is equal to 0. So remaining amount is equal to 0. Oh, how do you do a ternary thing in Python? Python, how ternary operator. Blah if blah else blah. Oh, okay. Return. So return the coin count if remaining amount is equal to 0, else -1. Wow, look at that. No! Okay, what's going on here? Let's use this test case. Wow, we aren't even close. Only 51 of 189. Am I even on the right track? Output is 20. Let's see. Is it because that actually using the largest coin first is not guaranteed to give me an answer? Do I actually have to try every single possibility? Is using the... Yeah, wait. Oh, I can think of a counterexample to my current solution. So what if... Oh my gosh, my handwriting. What if amount is equal to, I don't know, 14, right? And then my coins are like 13, comma 2. Yeah, this wouldn't work, would it? The answer would be 7 2s, but I would try 13 first. Dang it. I feel like we have to try every single combination, no? There's no other way. No, I was on the wrong track. Okay. Yeah, you know what? I'm going back to recursion. Amount is equal to... Okay, what's our base case? If amount is equal to 0, then... Well, yeah, if amount is equal to 0, then you return, then that means our problem is solved, right? Return 0. Because we need 0 coins to add up to amount. Else, for every coin in coins, you would probably do like a recursive call, right? Function coins the current amount minus the current coin value. And then you would do a 1 plus over here to symbolize the coin that you used. Yeah. And then you would take a min over here. Yeah, okay. What happens if the amount becomes negative though? Amount is less than 0? Then you would probably return a bogus value like -1 or something, and you would watch out for that -1 here. Yeah, okay. I think that's the plan now. That's the plan. All right, back to recursion mode. So we would need to store, you know what, I'll just go with this. So if amount is less than 0, return our bogus value of -1. I spelled amount wrong. Else if the amount is equal to 0, return 0. Else our recursive case is for every coin in coins. This is wrong syntax, isn't it? It's supposed to be in. Okay. We need a recursive call, so coin change of the same number of coins. The set of coins we use remains the same. Amount minus coin. Okay, what do we do with this call though? Ways is equal to coin change if ways is not equal to -1, which is our bogus value. I keep forgetting that Python, you don't need parentheses. We need to track our lowest ways first. Min coin needed, I'd call this min coin needed, is equal to float infinity. Is this how you represent infinity in Python? Yeah, I think so. I'm gonna rename this to coins. Coin needed. So if the coin needed is not equal to our bogus value, then you do min coin needed is equal to the min of the current min coin needed and the current coin needed. Okay. I feel like that's it, no? And then you return min coin needed. Coin change is not defined. Oh. Self.coin change. Oh. I know it's wrong. Oh wait, no, I don't know what's wrong. Time limit exceeded for this one. Let me remove this temporarily. Let's make sure that the recursion actually works at a basic level. Oh, okay. Output is 0. Yep, I saw what's going on. Coin needed is equal to, we have to add the current coin. Oh wait. 1 plus the coin needed. Okay, we're getting somewhere. What is null? Oh, because there's no solution, right? Min coin needed. Oh, interesting. So if min... So return min coin needed if min coin needed is not equal to float infinity, else -1. Yeah, let's go. Okay, I'm gonna hit submit. We're gonna get time limit exceeded, and then it's time to do some memoization. Yep, it's going. Time limit exceeded? Yeah. We got it. We need to add in a cache. I'm thinking, so the only changing variable is the amount, right? We probably need to wait, the only thing changing is the amount. What is the range of amount? We'll probably need some sort of dictionary then that stores the min. Yeah, the min coins, min number of coins needed per amount, right? 10 to the 4 doesn't seem that bad. It's like 10,000, right? Worst case, the array is going to be 10,000 long. Okay, let's make the helper function. The helper function is going to be pretty similar here. I'm going to call this helper here, and it's going to take in another list of ints. I'm going to call this cache. Okay, so another base case now is if cache of the current amount is not equal to our bogus value, let's do -1. Yeah, then you return literally the cache amount. Okay, and then before we return our answer, we need to store it first. Result is equal to that cache amount is equal to the result, and then you return the result. Also, for your recursive calls, you need to pass in the cache again as well. I think that's how it works. Python, do we pass objects as pointers or value? Passing references to objects by value. Okay. Okay, and then in the main function, our cache will begin as this. Cache is equal to -1 times amount from 0 through amount, right? Does that mean we'll need one more index to account for the 0? Because 1 through amount is already count amount, so amount plus 1. Yeah, I think that's right. And then we call helper return self.helper coins, the amount, and the cache. Hopefully this works. Takes 3 positional arguments before we're given. Oh, it's the helper. Please. Oh, did we do it? Please. Work. No. Come on, let's use this test case here. Can we print if we're actually hitting the cache at all? And cache hit with the amount. Okay, we're making cache hits. Uh-oh, why is it so slow though? Are we hitting the same numbers multiple times? Okay, let's remove case 4 first. Let's see the cache hit results for the previous ones. Okay, there's a problem. We hit cache 1 multiple times. Wait, that's normal, right? That should be normal. Can we store when we're storing stuff into the cache? Print cache. Storing in cache. Amount. One, two. Huh, we're making pretty efficient use of the cache. Is there some Python concept that I'm missing here? I'm gonna ask. I feel like there's some sort of Python concept I'm missing, because this usually works in Java. Let me ask ChatGPT, best friend ChatGPT. Leetcode problem, coin change. Why is this solution too slow? Too many recursive calls. Ooh. Python function call overhead. Bottom of DP. Do I have to pass the cache as a function, as a parameter? Oh, it's an instance variable. Would that help speed stuff up? No? Okay. So you could do this self.cache. 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 And then no need to pass the cache in here. Self.cache. Oh wait, this is never gonna work because all the print statements. Still time limit exceeded. Wow. Is opening recursive frames in Python really that expensive? I swear the solution works in Java. What is the solution here? Okay, so they start an array with float inf times amount plus 1. dp0 is equal to 0 because you need 0 ways to add to 0. Okay. For amount in range 1 through the amount, for coin and coins, if a minus coin is greater than or equal to 0, then the best solution at the current amount is equal to min of the current solution, and 1 plus the best solution, dynamic programming of amount minus that coin. I guess that makes sense. Return dp amount if dp amount is not equal to infinity, else -1. You know, that kind of makes sense. Sure, let's try that. Float -infinity times amount plus 1. This is our, let's call this our results. So we have indices 0 through the amount. That should be what we need. Results 0 is equal to 0 because the number of coins you need to add to amount 0 is 0. And then for every possible amount for A in amount we need to try every possible coin, right? For every coin in coins. So results of A is equal to the max of either the current results A, maybe we tried other coins in the past, or 1 plus result of like the best answer of the best outcome of using amount minus the current coin that you're trying. 1 represents that coin that you tried. And we have to watch out for this too. This could be indexed out of bounds, so if amount minus the coin is greater than or equal to 0, then you do this. And then in the end, if you would return results of the best result of the current, like the requested amount, if results amount is not equal to this bogus value over here, else return -1. I feel like this makes sense, right? For every possible amount from 0 through the requested amount, for every coin in coins, if using the current coin on the current amount, this is the current amount is A minus coin, A minus coin. So if using the current coin on the current amount is greater than or equal to 0, meaning its index is in bounds, then the result A of the current amount is equal to the max of the current best solution, or 1, representing the current coin that we're using, result A minus coin. Let's try running this. A in amount int object is not iterable. For I guess results length, the length of results. So it would iterate 0 through we need to iterate the indices 0 through amount, right? So it's more like A in range of the length of results. So like amount in range amount plus 1. So 0 through amount. Result is not defined. Results. Output is null. Expected 3. Everything is null. Fantastic. Oh wait, we're supposed to take the minimum coins, right? So it would make sense if results is starting off as infinity, and then we can more conveniently take the min. Why? Results amount if results amount is not able to float to infinity. Can we print out what results is? And what happened to all these indenting? Let's print results. One through 5, there's 11 places. Okay. We are getting to 3 over here. Okay. So why are we outputting null? Results amount if results amount is not equal to float to infinity, it's -1. Well, yeah, why are we returning null? Oh, I don't have a return statement. Return. It's 12 a.m. Alright. Output is -1, expected 3. Is it the indenting? I feel like we're only doing... It looks like we're only printing results out once. Something is up with the indenting, isn't it? Oh, there we go. Man, the indenting is so weird here. Submit output limit exceeded, no. Please. Oh, finally. Jesus. Chandu16 says nice, thank you. Okay, well, we learned one terrible news about Python. It sucks for recursion plus memoization. Like, I swear, my second solution would have worked in Java. In fact, I know it would have worked in Java because I've done this problem in Java before. Leah Kata Ali says keep going, heart. Thank you. Okay, let me write down what I learned here first, though. Oh wait, it doesn't even matter because I already erased my previous solution's code. Yeah, dang. Dynamic programming is painful in Python. I really enjoyed dynamic programming in Python. I mean, in Java. Because I could just do recursion and then memorize the result. Here it's like, apparently opening up frames in Python is just really expensive. So solutions that work in Java won't work in Python. That is such a bummer. So I actually have to understand all the dynamic programming solutions now. What a bummer. Dang. Should I write this problem down for review? I feel like I should. So what I just did was, man, we didn't even do dynamic programming for climbing stairs. We just did Fibonacci. Well, we kind of did we? Maybe I should actually start understanding bottom-up dynamic programming. It is a bit shorter to write. Okay. Yeah, not too happy about this discovery I made about Python. I have to actually understand dynamic programming now, no. Okay, so climbing stairs. I basically have to review both of these problems now, because I couldn't do them the first try. Climbing stairs. Coin change. Yeah, hopefully it'll get easier as time goes on. Review problems. Okay, you know what? I think that's enough torture for today. I actually had to understand dynamic programming for both problems. I'm gonna drop off for now. Thanks everyone for coming. Thanks. Leetcode Ali, Chandu16, Kinoe, Pseudoplis. Oh, there's actually a lot of new people here. Thank you, I appreciate. I'm gonna go to sleep now. It's 12:30 a.m. in my time zone. See you guys next time. Bye.